Okay, this was the last 14 minutes of a sunset, uh, August 14th. From a very low perspective, I was about 3 foot off the water. And, I always like to say that I guess it's all in the eye of the beholder, because of the way I see this, is that sun just get further and further and further away, just like the two parallel lines converging on the horizon. At a point, you won't be able to see the line. And this is what, Wolfie doesn't want to explain soundly, that, they say, oh, the sun stays the same size. The sun stays the same size. Put a filter on it, put a filter on it. Even with a filter on it, you're going to get the same effect that this small little dot of light is going to totally vanish. As soon as I get a filter for my new camera, I will be putting one on, and we will test it with a filter on it. I'm not going to zoom way in on it. We're going to stay out so we can still get some light and see clouds and whatnot that's out there on the horizon. Now, I did speed this part up 2 times, only because I wanted to make the video shorter, but I was zooming in a little bit at a time, and that's what I usually like doing, but I didn't want to zoom in real far, because sometimes the whole screen goes black and you don't get to see anything around it. So I always think it's important that I stay back a little bit, because you are losing some of the appearance of what you would be seeing. And just think, if the next guy out on a boat, say every 10 miles, what they would be seeing, and would they all be visible within each other if it was a clear day? Most likely, especially, if they had a telescope or, binoculars, they'd easily see each other. Now, this part here, I slowed down to normal speed just to show you. I was zoomed back, showed you that I was at a low perspective, and then zoomed back in. And then I actually sped this part up 3 times because I feel ashamed. I feel ashamed because when I zoomed in, I was just watching with my eyes and not watching my camera. So I didn't get it. I didn't get it all the way into focus. So I do apologize for that. But I didn't want to cut this whole part out, so I sped this part up 3 times for the shame of it. Um, but you do get a little something out of it. I mean, it almost looks like the sun's being squeezed through the clouds, but it's not, because we know, of course, people with any common sense in the flat Earth community knows that these clouds are not uh, in behind the sun. It's just the sunlight appearing to cause it to, um, all these areas. You could look up and see the light through the sun anytime, or the you could see the light through the clouds anytime. Some of the clouds are thin, some of the clouds are thick, and you can see this if you go out and just observe it with your own eyes. Get a little zoom camera. It doesn't have to be a big one, but you could do it yourself and very much see. All right, now here I got it back into focus, and I decided to just let it go at normal speed. It was windy this day too, so that was another reason why I didn't want to zoom in, because I zoom in and everything starts shaking with this P1000. Um, even with I did strap my camera down one day, not really very well, but it didn't seem to help when I was zoomed way out. So, on calm days, you can zoom way out and probably have a heck of a lot less issues with it. But on windy days, it's hard to even tell if you're in focus. But watch this sun as it, you've seen how it rose up out of the water and it met with its own reflection. Now, all it's doing, just like boats, because you can never get away from the mirroring, the miraging out on the far horizon. Now, some days, yes, you got less miraging, mirroring. So what it does is it allows you to see further on different days and less on other days. In other words, things seem to get cut off sooner than what they should if it's on a clear, visible day. And this is where everybody that looks at these videos say, well, right there you're proving that the sun's setting behind the curvature of Earth. No, I'm not. What I'm doing is proving convergence of a light that's converging on the horizon. And what it did was it blended in with itself, and it will continue to blend in with itself until it gets to the point where it rises back up off the water, and you'll watch it get smaller and smaller and smaller to the vanishing point. That's to the vanishing point. You can no longer pull it back after it's at the vanishing point. That's the convergence point where everything converges into the horizon. You can no longer see past that. And the only way to do that, to get, to see it again, is to increase your height. And that would even include on a flat surface. Think about the parallel lines. You're going to have a flat surface meeting another line, and that line's going to vanish into it, and you cannot see past that point. That's the x-axis, or whatever you want to call it. Let's watch that again in slow motion and see what you think here. Because, again, you got to really watch it to see how it vanishes. So I slowed this down 3 times, I believe. Yes, it was 3 times. And watch it. It's still the same sun. And it's going to rise back up off this water because, see, it's still mirroring itself all the way to the vanishing point. It's mirroring itself. But it never goes over the curvature. It just goes beyond your vision. It goes to that vanishing point. Thanks a lot for watching. I hope you like this, because I did.